When we think about black holes, it's easy to picture these sort of cosmic vacuum cleaners, right? Just silent voids out in space. But the reality? Oh, it is so much more extreme, and honestly, way more interesting. Today, we are going on a tour of the universe's real monsters, the biggest, the baddest, and the most important black holes we've ever found.
So, let's kick things off with a huge question. What's the single most powerful force in the entire universe? It's not some massive star going supernova, it's gravity. But it's gravity cranked up to an absolutely unimaginable extreme. The kind of gravity that literally rips the fabric of space-time apart. The kind you only find in a black hole.
And this is what we're dealing with. At its heart, a black hole is basically a point of infinite density. And that border around it, that's the event horizon. You've heard of it. It's the point of no return. Once anything, even a beam of light, crosses that line, it is never, ever getting out. It is the ultimate one-way street. All right, here's the game plan for our tour. First, we'll meet the cosmic heavyweights, the biggest of the big. Then, we're going to dig into some really deep puzzles from the dawn of the universe. After that, we'll check out some of the more exotic types of black holes. And finally, we'll get into why these monsters are so incredibly important for science.
Okay, first up, let's talk about sheer scale. I mean, it's one thing to say a black hole is big, but it is something else entirely to wrap your head around the numbers. These things aren't just big, they are absolute titans that make our entire solar system look like a speck of dust.
Just look at that number for a second. 66 billion. That is the mass of the black hole at the center of a quasar called TON 618. And that's not 66 billion pounds, that's 66 billion times the mass of our sun. It is, without a doubt, one of the most massive things we have ever found in the entire universe. Now here's how you really visualize that insane number. The event horizon of TON 618, that point of no return, is so huge that you could take our whole solar system, from the sun all the way out past Neptune, and just drop it inside, and you'd still have plenty of room to spare. You could do it over and over again. It's just mind-boggling.
And this just goes to show you that not all supermassive black holes are created equal. Over on the left, you've got our guy, Sagittarius A star, a perfectly respectable 4 million solar masses, but he's pretty quiet, kind of chill. But then you look at M87 star. We're talking 6.5 times billion solar masses. This is a true powerhouse. This is the one we actually took a picture of, and it is blasting a jet of pure energy 5,000 light-years out into space. That is power.
So, size is one thing, but now we get to the really big puzzle. It's not just how big these things are, it's how they got so huge, so incredibly fast. The oldest monsters out there are making astronomers rethink basically everything about the early universe.
Okay, look at this timeline. The universe is about 13.8 billion years old. But this monster, STSJ 0100 plus 2802, was already 12 billion times the mass of the Sun when the universe was less than a billion years old. That's like a baby suddenly weighing as much as a blue whale. It shouldn't be possible. And that leads us to the central mystery, right? How on earth did these things grow to be so massive so quickly? Our standard theories, that they slowly slurp up gas or merge with other black holes, they just don't work fast enough to explain this. There wasn't enough time. And here is another one that's just breaking all the rules. The black hole J2157 isn't just huge, it is ferociously hungry. It is swallowing the mass of our sun every single day. Now, this rate of growth is so extreme it completely shatters something called the Eddington limit. That's supposed to be the cosmic speed limit for how fast a black hole can eat. This one just blows right past the stop sign. So how? How is this possible? Well, one of the coolest leading theories is something called a direct collapse black hole. The idea is that way back in the early universe, you could have these absolutely enormous clouds of gas that were so massive they collapsed directly into a huge black hole seed, completely skipping the step of becoming a star first. That could be the head start they needed. Okay, so we've been all about the supermassive giants so far, but the world of black holes is way more diverse than that. Trust me, it is not just about size. Some of the most fascinating and powerful black holes come in, well, more exotic flavors. This lays it out perfectly. You've got your stellar mass black holes, like Cygnus X-1, which are born when a single giant star dies. Then you have the supermassive ones we've been talking about, but check out that one in the middle, intermediate mass. For years, these were the missing link we couldn't find. Objects like HLX-1 are our first real glimpse into this mysterious class.
And we have to give a shout out to Cygnus X-1. Yeah, it's only about 20 times the mass of the Sun, but it's a legend. Why? Because this was the one. This was the discovery that took black holes from being a wild, theoretical idea on Einstein's blackboard and turned them into a real, observable thing in our own galactic backyard. A total game changer.
And then you get systems that are just pure cosmic drama. In a system called OJ-287, we are literally watching a smaller black hole orbit a behemoth that's 18 billion solar masses. And twice every 12 years, like clockwork, it plunges right through the massive, blazing hot disk of gas surrounding the bigger one. This collision creates a predictable flare of light so bright we can see it from Earth. It's incredible.
So, we've met the biggest, the oldest, and the weirdest. Which brings us to our final and maybe most important point. Why do we even care? Why does studying these cosmic monsters actually matter? What do they really teach us about the universe?
Well, here's the big takeaway. Black holes aren't just voids of destruction. They're cosmic engines. They're the power source behind quasars, the brightest things in the entire universe. They act as gravitational anchors that literally shape how galaxies form and grow. And maybe coolest of all, they're the only place we can test Einstein's theories to their absolute breaking point. And maybe, just maybe, find clues to a whole new kind of physics.
I think this quote just captures it perfectly. When we're studying black holes, we are literally staring over the edge of what we know. We're looking at a place where our current laws of physics just stop working. And that boundary, that edge between the known and the unknown, that's where all the most exciting discoveries are waiting. And so that's the thought I want to leave you with. The monsters we've talked about today, they're just the ones we've managed to find so far. As our telescopes get more and more powerful, as we peer deeper and deeper into that cosmic darkness, what other extremes are still out there just waiting for us at the edge of everything?